Hello class, welcome to Weather School. I'm ABC 21 Chief Meteorologist Matt Leach, and today I'll be your weather professor.
Matt's Weather School from ABC 21, brought to you by the Maumee River Basin Commission.
You know what? This feels a little too formal. How about this? I love that trick. Okay, 1 million extra credit points if you can answer this question in the next 5 seconds. Yeah, 1 million extra credit points. Have you ever had that many before? Okay, what is the only major weather event that you can't see, or that's basically invisible? Anybody? Anybody? If you said wind, you get the 1 million extra credit points. Am I authorized to give that? Anyway, you get it anyway. Now, why is wind so important? Well, it's actually the major driver of weather across the world, and without it, we'd all cease to exist. Now, because the Earth is round and it rotates on a 23.5-degree axis, the Earth isn't necessarily heated very evenly. Warm air rises near the equator. That's the middle part of the world. And then cold air sinks from the polar regions, from the north and from the south. It creates these kind of conflicting air masses, forming currents of wind that affect the entire world. One of these currents is actually called the jet stream. The jet stream is tens of thousands of feet in the air where planes fly. Meteorologists actually refer to the jet stream as an atmospheric river because these currents are always moving. Now, sometimes with this jet stream, it can dip a little bit because of cold air to our north. That brings us these cold, frigid days in the winter. But sometimes there can be a bump in the jet stream, and that causes warm air to rise from the south, giving us those really hot and humid days in the summer. By the way, did you know the hottest temperature ever recorded on planet Earth is 134 degrees Fahrenheit in Death Valley, California? We really could have used a dip in the jet stream that day. Now, these wind currents, or the jet stream, isn't like the lazy river at some water park. It's actually really fast. Did you know on average the jet stream can race at about 110 miles per hour? I wonder how fast...
Well, I guess I have a pretty good idea now. Look, I'm at the Auto Research Center in Indianapolis, and the wind tunnel I'm in is going at about 50 miles per hour. Only 50. It's not even a severe thunderstorm. Can you imagine wind speed being twice as fast as this? That's basically our jet stream, tens of thousands of feet up into the air. Here at ARC, they actually test the wind on a variety of different model vehicles like semis, cars, bicycles, even military vehicles to see how wind impacts these things on the road. Let's learn a little bit more about this.
So this is the model, a scale model of the wind tunnel that you were just standing in. We designed this about 20 years ago, and it's designed with an eye towards transportation. So anything that has rolling road where the wheels are spinning, that's the key to this tunnel. The neat thing about working in the tunnel is the fact that sometimes you find things that you don't expect necessarily. You know, you change one little part and it has a huge effect on that. Like I mentioned before, trucks have skirts on them, and such a seemingly simple piece, just a flat plate, can actually reduce fuel consumption by about 5%.
Wind is also a natural resource that can be converted to electricity through something called a wind turbine. Look how huge these things are. The wind spins these giant blades that in turn spin a generator, which will then create electricity. And in the flat landscape of the Midwest, it's no wonder that these things can get quite a workout.
Wind turbine is constructed so that we can generate electricity. And the wind turbine itself uses no fuel. So it's a free source of energy in the environment. And we use these wind turbines. Each that you see behind me is what's called a utility scale turbine, and they each produce 2 megawatts of power. Now, how much is 2 megawatts? Roughly enough for about 500 homes. So our wind farm is 152 of these wind turbines. We produce up to 304 megawatts of electricity, which is roughly enough for about 75,000 homes.
Mother Nature's natural air conditioning. You know, the reason why we have wind at the lake or the ocean is primarily because of something we talked about earlier in the show. Warmer air is lighter, or high pressure, and you find that at land. On the water, though, it's a little colder, it's a little more dense, and therefore you usually see low pressure. This high and low pressure typically competes with one another and thus creates a cycle of air, or a current, thus keeping things just a little bit cooler along the lakeshore. Wow, you hear that? A storm's rolling in. So when thunder roars, it's best to go indoors. So let's head back to school. Oh, come on, really? I can teleport just about anywhere except for back to school. Okay, now I have to admit, thunderstorms are probably my favorite weather event, especially hail. You don't believe me? Take a look.
Don't, please.
Yeah, we had to buy new windows after that scream. You know, hailstones are pretty cool. It's kind of like big ice cubes falling out of the sky, and the more I think about it, the more terrifying it sounds. Anyway, scratch the imagery. Hail, while it can be really dangerous to cars, to roofs, and to your noggin, it's still a pretty interesting process and fun to figure out. Let's talk a little more about how hail forms. Clouds are essentially a collection of tiny water droplets. When storms develop, these clouds become more unstable and wind rushes in and out of them. If these gusts, called updrafts, lift little water droplets above the freezing layer in the atmosphere enough times, a thin layer of ice will form. The size of the hailstone depends on how many times it gets tossed and thrown around the cloud's freezing layer. Eventually, the updraft isn't strong enough to keep all the hailstones in the cloud, and they fall to the earth. Now, hailstones can range in size. It can be as small as a little pea, to about a quarter, to as big as a grapefruit. In fact, the biggest hailstone ever recorded was 8 inches in diameter. But let's go back to the grapefruit. I mean, can you imagine a grapefruit falling from the sky? Something that big? I mean, that'd be pretty cool, of course, but dangerous. But really cool. Now, hail isn't the only thing to look out for in a thunderstorm. For this next part, we're gonna have to do a little bit of storm chasing. See that? You've got storms in the distance, and a little bit of lightning too. And that's actually the most dangerous part of a thunderstorm. Now, we're not going to stay out here for long, but I did want to demonstrate a few things for you and talk about lightning a little bit. Lightning can create heat 3 times hotter than the sun, travels at about 60,000 miles per second, and is not very wide, coming out to only about 1 inch in diameter, or about the thickness of a pencil lead. So what creates this electric shock? Remember the hail we talked about a minute ago? Those ice particles carry negative energy towards the bottom of a cloud, whereas the Earth's surface and the top of clouds produce positive energy. And what happens when opposites attract? Yeah, that sound, that's thunder, or essentially lightning hitting the Earth's surface or particles in the sky. Look, another lightning strike. Okay, start the timer. Let's conduct an experiment. For every second that passes when we see lightning and hear thunder is about how far away the storm is. Okay, that was about 5 seconds, right? We heard thunder again. That means the storm is about 1 mile away. But if it takes about 10 seconds between lightning and hearing thunder, the storm is about 2 miles away, and so on. Pretty cool, huh? Okay, those clouds are looking a little dark, a little ominous. We better head back into the storm tracker to get to safety. It's actually a good thing we do, because our next weather lesson is on tornadoes. So we better buckle up and get to shelter. Whew, that weather got bad in a hurry. And you hear that? That's a tornado siren. And you know what that means? Better head down to the basement. Okay, I'm hunkered down in the basement with my pal Gunther. And that's another thing to keep in mind. When there's a tornado warning or even a severe thunderstorm warning in effect, you're going to want to head to a lower level of your home, like a basement. But if you don't have one, an interior room works really well too, like a closet or a bathroom. It's also pretty, let's see. It's also good to have your phone ready too. We have our ABC 21 weather app. You can also get a weather radio, but it's good to keep your phone charged because not only does it have light, but it can give you life-saving weather information as well. And you know what else can be life-saving? Helmets. I know it seems really weird and maybe a little awkward, but the most important part of your body is your head, and you want to protect it just in case there happens to be any flying debris. And you know what else is also important? A little helmet for Gunther the weather dog. Let's see how he appreciates getting this put on. Although tornadoes are beautiful, that doesn't make it a good idea to get up close and personal with them. One of the most important ingredients for tornado formation is warm, moist air at the surface and cold, dry air above. The next ingredient is strong surface and upper level winds. This clash of temperature and fast-moving air causes some rotation in the middle levels of the atmosphere. With strong enough updrafts and turn in the atmosphere, this rotation can become vertical and emerge from what is known as a wall cloud, or the base of the supercell. If it doesn't reach the ground, it's only a funnel cloud, but if it does, we have ourselves a tornado. Now, what about here at home? Could we see tornadoes? Yeah, the answer is yes, but this far north, tornadoes only happen once in a while, and most of the tornadoes we see in northern Indiana and Ohio are small. Each year, the state of Indiana sees an average of 22 tornadoes, whereas Ohio gets an average of 19. June is the most active month in terms of tornadoes, with July and May coming in second and third. December remains the only month with 0 recorded tornadoes. No worries for Santa Claus as he comes our way. So how big can tornadoes get? Tornadoes are measured on the enhanced Fujita scale, named after meteorologist and tornado researcher Dr. Ted Fujita. An EF0 is a tornado with wind speeds of between 65 and 85 miles per hour. An EF1 packs winds of 86 to 110 miles per hour. An EF2 of 111 to 135. An EF3, 136 to 165. An EF4, 166 to 200. And can you believe this? An EF5 tornado can have winds over 200 miles per hour. Now, we can get some tornadoes that are on the bigger side here at home. Just ask one of our ABC 21 viewers who lives in Ohio and was impacted by a pretty big tornado.
It was something you can never prepare for. You always hear the stories about, how someone had nothing but the clothes on their back, which was pretty much what we ended up with. You look around and walls are gone, and you find, we were finding about 1.5 miles down the road, someone found the family picture of ours that was hanging on the wall in our living room just 20 minutes prior. Just pay attention, and even if you don't think it could happen to you, it could, and you just need to be prepared for anything.
So again, tornadoes can and do happen here in northern Indiana and northwest Ohio, but they're usually small. Doesn't mean they're not dangerous, but they're not quite as big as the ones further to our west, like in Oklahoma or northern Texas. But even as I say that, larger tornadoes can and do happen here. Oh, look at that. The tornado warning has been canceled, power's back on. That's perfect timing. Gunther wants to go back outside. Oh, wow, isn't the weather around here crazy? Stormy one minute and then beautiful the next. That's kind of one of the things I love about the Midwest weather. Well, Gunther really wants to go on a walk now, so that's what we're going to do. But remember, anytime you see those clouds billowing in the distance, you hear thunder, you see lightning, or you hear a tornado siren, make sure you head to cover. Come on, Gunther. Well, class, we've covered a lot of weather so far. Wind, hail, lightning, even tornadoes. But we haven't even covered the costliest and most dangerous weather event of all. And I bet it's something you haven't even thought of. I was born and raised in Seattle, Washington, and that always gets a bad rap for all the rain it receives. But did you know that northern Indiana and northwest Ohio actually receives almost a foot more rain per year than Seattle does? It's true. But because Fort Wayne's kind of a low-lying area, and much of the Midwest, flooding is a big concern. Fort Wayne's pretty well equipped to handle flooding these days, but it hasn't always been that way. The earliest recorded flood in Fort Wayne's history happened in 1790, 4 years before the city was officially established. In late March 1917, a devastating heavy rain event swept through Indiana, once again flooding Fort Wayne. Then, in early March 1982, heavy snow blanketed the city, but a rapid warm-up with heavy rain weeks later led to one of the most devastating flooding events in the city's history. Thousands of people had to evacuate their homes, and President Ronald Reagan declared Fort Wayne a federal disaster area. Since then, the city has built up and around our area's rivers and low-lying spots, keeping the bulk of the rain and river water in Fort Wayne's parks instead of Fort Wayne's homes. So again, history has proven that northern Indiana and northwest Ohio can receive some pretty bad flooding events, even if it is better today. And that's why we tell people don't underestimate flooding waters. Look at it this way. I'm 5'8" tall, so just a few inches of water, even up to my ankles, that can cause a big problem. I could even lose my footing. Now, think about a foot of rushing water that goes right up to my knees. Yeah, that's difficult to wade through, but sometimes it doesn't look like it's that deep when you're driving or walking. So just remember, turn around, don't drown, especially if you don't know how deep that water is. Whew. I don't know, is it just me, or was there a kind of chill that moved in? I don't want to make any promises, but I feel like it could snow soon. That's what we're going to talk about in our next segment. In the meantime, I don't know why I wore a short sleeve shirt. Better grab the jacket. Ah, that's better. Isn't winter so great? You've got the holidays to look forward to. You can wear big, warm coats. And also, there's snow. And I know everyone loves snow, especially when school is canceled. But it's not just about snow. There's other winter weather events that want to be in the spotlight too. And this is where our next chance for extra credit comes into play. You can get 2 billion points of extra credit if you can remember all 4 of the following winter precipitation types we're going to talk about now. All right, let's begin. The kind of winter weather you see depends largely on 2 things: the temperature at the surface, where you are, and the temperature above the surface. When the temperature is above freezing at ground level and way up high into the clouds above, what falls out of the clouds will be rain. However, sometimes the ground is still frozen after a cold day. while the air higher up is above freezing. In this situation, you'll have rain fall but immediately freeze or supercool when it hits the frozen ground. You know what we call this kind of rain? Freezing rain. I know, creative. Now, sometimes it's not just cold at the surface, but also a few hundred feet up in the sky, too. In this instance, rain will fall but cool into little ice balls moments before hitting the ground. If you listen closely, hear that? You can hear these little ice pellets or sleet hit the ground. Pretty cool, huh? Finally, when the temperature is below freezing, way up in the clouds and down below at the surface, what falls out of the clouds and sticks to the ground is snow. This is my personal favorite, of course, because the possibilities are endless. I mean, think about it. You can build a snowman, make a snow angel, have a snowball fight, eat the snow. Just don't eat the yellow patches, of course. Or just sit by the window and watch it gently fall down. Of course, when you're an adult, you'll occasionally have to drive in it. So if you can't wait to be a grown-up someday, just remember, you'll have to pay taxes and drive in snow. Trust me when I say, growing up is fun. It just isn't quite that fun. It can wait. So did you get it all? All the 4 winter precipitation types? We have rain, freezing rain, sleet, and snow. If you got all those right, that's 2 billion extra credit points. Imagine what you can do with all that. Okay, we're not quite done with the snow yet. Have you heard of lake effect snow? For this part, we better head back to the classroom.
While we don't get much lake effect snow here, we can get it every once in a while. So let's talk about how it works.
Remember our discussion on wind? Warm air rises, so when a cold weather system moves over a relatively mild body of water, like a lake, moisture gets sucked up into the clouds. Because cold air is heavier, once the storm system reaches land, the snow spills out from the clouds, with the heaviest amounts closer to the lake shore and lighter amounts further east.
Let's look at it this way. I've got a demonstration. We've got our lake water here. We've got the land. We've got the clouds.
As the cloud passes over the water, which is warmer than the land, water vapor rises and fills the cloud, or the sponge, with water. Then the storm passes over the colder land, and the storm releases the moisture, with the most moisture closest to the lake and less moisture away from the lake, like so.
So if you really want to see that big snow, like cotton balls, you're probably going to have to go to Lake Michigan, where they get most of the lake effect snow. But you know what's even more exciting than just seeing the lake effect snow itself? Seeing the snow up close.
Snow and rain pretty much start out the same way, as little ice crystals high up in the clouds. But if it's cold enough, these ice crystals can grow, creating snowflakes. A snowflake's design is pretty complicated, though, and depends a lot on temperature and the amount of moisture available in the clouds. This is why you're not likely to see any 2 with the same design, though you can find some that are similar in their overall shape. 3 of the most common snowflakes are 1, hexagonal, which is 6-sided and flat, 2, stellar, which is when the snowflake branches outward like a star, and 3, needle, which can be solid or hollow and typically forms on the coldest days.
And did you know you can actually observe these snowflakes really close? ABC 21 viewer Carl Rockwood actually takes these pictures of snowflakes as a hobby and explains it a little more.
In the winter I go out, I use Polartec black fleece. I put this over my recycling bin, and I allow the snowflakes to fall down and impact upon it. I search for them by using light and scanning the fleece until you can physically see a snowflake. They're about 1 millimeter in size. Then once you find a snowflake, you got to do this very rapidly because a snowflake is going to melt due to sublimation and infrared radiation. So you've got to get on your snowflake, locate it, and take your shot. Because I didn't do very good the first year. I was frustrated, but I kept making gradual improvements to technique. It was all me. It wasn't the camera lens. I was making errors as I was shooting. Last year, I shot some absolutely phenomenal snowflakes, and I'm now obsessed with it.
You know, of course, snowflakes are beautiful, but you know what else is beautiful? Rainbows. Isn't that pretty cool? I've never seen a pot of gold at the end of one. Maybe one day. But rainbows are pretty cool, and you can see them in the spring, in the summer, basically as long as you have 2 ingredients in place. Number 1, some sunshine. Number 2, a little bit of rain. In fact, you can create your own rainbow at home. Just bring out the sprinkler, spray a little water around, fan it around during a sunny day, and you can see the light bend in the raindrops and create those cool colors. So let's talk a little more about how rainbows form.
Sunlight bends through these raindrops at various angles, creating bright colors. The colors you see are almost always in the order of red, orange, yellow, green, blue, indigo, and violet, or Roy G. Biv, because of how our eyes process the bending of light. Now, what about the double rainbow? Now, this is where it gets a little crazy. Sometimes you'll see a rainbow give off a reflection of itself. This is because light will occasionally reflect twice off of the back of a raindrop, acting as a mirror to the original rainbow. This is why the secondary rainbow appears to be the opposite, kind of like when you look in the mirror. I wonder if there's twice as much gold at the end of these. And then there's the northern lights. You see these beautiful colors dancing across the night sky? What you're actually seeing are colorful electrically charged collisions between sun particles and the gases in the Earth's atmosphere. Without this atmospheric protection, these particles would penetrate the Earth and could do a lot of damage. Ooh, and what about fall color? In the spring and summer, trees usually receive all the nutrients they need to produce vibrant green leaves. However, these nutrients break down in the fall due to many things like temperature changes, the amount of rain we receive, and less daylight. Depending on the type of tree and the type of fall weather we see, green leaves will transition to oranges, reds, yellows, or browns. As long as the fall isn't too extreme one way or the other, fall color can be quite bright and vibrant. No way! Weather school's already done. Can you believe it? I don't know about you, but I've had a lot of fun. We've talked about invisible weather like wind, colorful weather like rainbows, tornadoes, lightning, hail, even Gunther the weather dog made an appearance. And you better believe he's going to remember that helmet during the next tornado warning. Okay, I get it. Weather school is really done, but that doesn't mean you have to stop learning. Weather is full of surprises, and who knows, maybe one day you'll end up studying the weather too, and even presenting it on TV, like me. Have a good day, and keep on learning.
Matt's Weather School from ABC 21, brought to you by the Maumee River Basin Commission.